there's the new little fella that we got to see. He came Thursday. He's doing great for 6 weeks early. His lungs are great. He didn't, was worried his lungs wouldn't be fully developed yet, but they were. Little guy's doing great. So here, I got a couple more pictures. There's a closer picture of his little face, and full head of hair, man. Full head of hair. And see, there's another picture of him. They were giving him some food because he's learning. Apparently, at 34 weeks is when you first learn to like suck and swallow. So he's having trouble learning how to eat a little bit, but he did good. And then I got a picture of my wife, grandma, holding that little baby. He's 4 pounds and 13 ounces, little fella, since he was born 6 weeks early. But he was 18 and a half inches long. So he's a pretty long little guy for the size of him. But there's the little guy. There's the little guy right there. So it was a long, exciting weekend. I spent a lot of Saturday and Sunday up at the hospital with my daughter and my son-in-law, and her sister was there. Her in-laws from her husband's side was there, and so it's a whole new, exciting world at our house. So the baby's probably going to be in there for a few more weeks. Could be up there up to 6 weeks with your preemie. You could end up staying in the hospital to your full term, but he's doing so well. I don't see him being in the hospital more than a couple of weeks, probably. Mama gets out of the hospital today. They had to do an emergency C-section, so it wasn't just like let's have the baby today. They had to cut her open, so she had like a major surgery as they removed the baby. So she's been in the hospital since Thursday, but she's gonna get out today. So we are getting there. Good stuff. So, all right, we need to look at our lesson for the week so that we know what in the world we're doing. I've already put the template in Google Classroom. So let's take a look and see what programming holds for us this week. All right, we're going to go to our grade screen. All right, let's see. If we scroll down to April 14th is this coming weekend. So we're starting Module 6. Last week we had the Module 5 exam. So we're doing testing, and we are writing a program right off the bat, a testing program. So let's go to 6.01. Go to the activity screen. We can close Module 5. And we'll skip the intro. The intro just tells you about all the lessons. So we need the testing lesson. All right. Testing 1, 2, 3. It's the moment you've been waiting for. Your server places the pizza of your dreams on your table. Extra cheese, piled high with all your favorite toppings. Seconds later, you grab a slice, take a bite, and was that cheese molten hot magma? I had that experience yesterday. I actually got pizza and I burned the top of my mouth. I was so hungry. I didn't wait. Of course, this horrible situation, well, the burn, not the pizza is not the horrible situation, could have been avoided with a little testing, right? I should have tested the pizza to make sure it wasn't too hot. Takes a little time, a little patience. But pizza is much more enjoyable when it's not the source of second-degree burns in your mouth. Because, I was brushing my teeth this morning and went, oh, yeah, I burned that. In programming, taking time to test is a crucial step in ensuring the quality and usability of a program. And it's the only way to avoid unplanned disasters. We can talk about those later. All right, so we're going to learn how to explain the types, uses, and limits of testing to ensure program quality, determine when in programming development types of testing are performed, explain how data and test plans are used, and describe the role of customer support and satisfaction when you release software. All right, let's look at page 2. Oops. Have you ever burned $125 million? NASA has more than once. In 1999, NASA engineers working as part of NASA's Mars exploration program had been communicating back and forth with the Mars Climate Orbiter for 9 months. But there was just one problem. The orbiter was speaking to NASA using metric measurements, and the engineers were replying back using English measurements. Of course, they didn't realize that until the orbiter was descending too low and too quickly into the Martian atmosphere, because it was talking metrics and they were talking feet and yards and miles. So it turns out the engineers failed to conduct a conversion test when they were developing it. They didn't realize they were speaking a different language. If they had, they would have caught this error. but it was too late and it kind of burned up because it went too low too quick in the atmosphere and burned up. So you may think errors of this magnitude are rare, but think again. I mean, software bugs cost the U.S. economy about $60 billion a year, according to a study by the National Institute of Standards and Technology. That's billion with a B. So considering the cost of errors and humans' tendency to make mistakes, testing is mandatory when you write a program. You need to test it. In fact, there are even different levels of testing that take place throughout the stages of the software development lifecycle. So these testing levels provide opportunities to identify errors and bugs before you release a program, and it gets expensive, annoying, possibly explosive if you're building something that's going to fly through space. Let's take a look. So unit testing, here's 8 different kinds of testing here. Unit testing, developers usually conduct this type of testing during code development. The goal of unit testing is to ensure that the sections of code are functional, that they meet the slated requirements and are working as expected. Let's see what unit testing, verifying sections of a single program. It's like running spell check after you finish each paragraph of your paper, right? So you test each section. You run a section, run the program. No errors. Okay, write the next section, run the program. I do that a lot of times when I'm testing these. Integration testing. When there's different components of a program that are connected, integration testing, which is defined as checking the connected parts of a program and their interactions, that ensures that the behavior and functionality of the program are working together as expected. Sometimes integration testing happens all at once, like a big bang. You throw it all together, see if it works. Sometimes it follows a specific order, top down, bottom up. Okay, let's put in this piece, let's put in the next piece. It's like making sure each paragraph in your paper supports your thesis and works together with the other paragraphs. System testing. So this type of testing ensures the entire system is working as a whole. System testing, defined as verifying that the behaviors of the entire system are working, as stated in the original system objectives. Developers test the program in an environment that's very similar to how the program will eventually be used. This type of testing is quite rigorous and often performed by a specialized testing team other than the programmers. Acceptance testing. Once used to be called user acceptance testing. That's confirming that a product's readiness and that the customer accepts it. This process is carried out by a quality assurance team. All right, so during this type of testing, the quality assurance team's goal is to catch little errors like spelling mistakes, or image errors where that's not the image that's supposed to be displayed, and also major errors like bugs that can result in a crash of the program. It's like turning your paper in and getting feedback from your teacher on how to make it better. Okay, this is your first draft. Here's your feedback. Automated testing. Sometimes your code could go on for miles. If you're writing these programs for a big company, it's long. There's potential bugs hidden that could take hours to find. So that's when automated testing come in. That's defined as testing that doesn't require a human to test it, right? Many developers run automated testing programs overnight so they can come back to work in the morning to a list of bugs that can need to be fixed. Usability testing. So this is when developers get to see their work in action. So during a usability testing, a chance to get actual users to try it out, developers let users play with the software to see if they can break it. All right, here's your program, guys. Use it like you normally would and see if there's a problem. Try to put in something that'll mess it up. This can help identify bugs that would have gone unnoticed because developers don't always anticipate the variety of things that users might do with the software. You think they're just going to do this, and actually they use the software for something else as well. It's like getting other people to read your paper and report back on things that worked and things that didn't. Regression testing. These days, it's pretty common for programmers to issue updates to the software. You get them all the time. Apps on your phone get updates, apps on your computer, even apps on your watch. Sometimes these updates cause big problems. So to help avoid these problems, development teams conduct regression testing. That's checking a new version of software against the older version. That helps catch crucial errors in the version changes. This is a standard part of any process, and it helps prevent angry messages from users, right? Don't just put out your update without testing it to make sure it doesn't cause problems with the old updates. It's like reading through your entire paper to make sure the new paragraph that you added still makes sense. All right, quality testing. There are many good practices for testing the quality of a finished product. Separation of duties, ensuring that each member of the programming team is aware of their individual and group responsibilities. ISO 9000, those are the international standards to maintain quality assurance. So there's names for that. Six Sigma, that's management techniques that reduce the likelihood of errors. And sandboxing is running software without risking harm to the computer running the code. They kind of box it in where it can't damage other components. So, all right, let's look at the next one. That's a lot of good testing terms there. All right, customer support. You may think of customer support as just like live chat on a website or a helpline where you can call somebody when you got questions about the software, and that is part of it. But customer support's a big part of creating software and providing it to the public too. It's how companies work towards customer satisfaction. So how else do customers achieve customer satisfaction? Usability testing. Usability testing is a kind of customer support routine that takes place ahead of an official software release. It's essential to gather data on how customers are going to use that software and what problems they might run into, so you can correct the errors before they become bigger issues. So data sets is important for that. How do you know what to test? So let's talk about data sets. Think of these situations. Your program may run fine when you use it, but another user may try something out you didn't plan for. Like maybe you didn't plan negative numbers in something. When they would enter some number in there, you're just thinking of positive numbers, and negative number caused all kinds of issues. Suddenly everything crashes. The software doesn't seem so great. So this is a situation or data set that you need to test. And that's where users can be helpful. They come into your software and crash it for you. Oh, when I entered a -6 in this field here, it crashed. Oh, okay, let me fix that. So they come in and crash it for you and create lists of information about situations when the software didn't work as expected. They'll create like a log. When I entered this for this field, it crashed. When I did this, it crashed. I mean, it may seem time consuming, but when you take into account the value of a happy customer, when your software finally works properly, it's totally worth it. So let's look at some different usability testing that happens. Explorative usability testing is used early in the process to validate the design approach as well as user understanding. So usually a prototype is developed and tested with the full user experience in mind to find important bugs quickly. All right, this is what the program's going to do. And they start using it and they say, oh, this doesn't help at all. We don't need a program to do that. We need to do this. Assessment testing. So assessment usability testing occurs throughout the process to evaluate real-time performance of the software. How effective is it? Is it overall usable? Does it use tools like debuggers? You use tools like debuggers to do this, which allow programmers to step through code line by line to verify it's working properly at all the different stages. Comparative usability testing compares products, designs, or modalities, evaluating the strengths and weakness. So testing a software program on multiple devices, that's important. Testing different approaches allows the programmer to identify what's working and where can I improve that. All right, page 4. Another crucial part of maintaining happy customers is regression testing. Programmers, once their awesome software hit the virtual shelves, they know their job's not done. Whether developing on a mobile platform, creating a new operating system, building applications to meet a business's need, before too long, you're going to need updates. And with any luck, the inevitable bugs that show up in the first few days will be minor and very few, but they got to be addressed. After that, customers usually come up with ideas for improvement, or they ask for some new functionality. Hey, could the program do this? So programmers don't say goodbye to software as soon as you build it and release it to the public. Software is usually a growing and changing experience. And customers want to know that the developers are going to maintain that experience with regular updates. Frequent updates make good software look even better. Well, if they work. So you may think you're providing some cool new update, but there's an undetected bug in the new version that creates some kind of security vulnerability, which happens a lot, or causes users to lose important data. Suddenly everything looks pretty bad. You'll have Windows updates a lot of times, and then there'll be another patch update just a few days later because the first update created some kind of security problem. People can hack in through some loophole that they left. So it's very, very common to be another update followed very quickly. Regression testing helps avoid this. Regression testing helps everyone look good. So let's check out 2 infamous bugs that should have been caught with testing, but caused users and companies some serious problems. All right, GoToFail. This was Apple's SSL bug, also known as the GoToFail, created a vulnerability in its iOS 7.0.6 update. It was an update they put out. A duplicated line of code, which was called GoToFail, resulted in skipping one of the verification processes, making it easier for hackers to hack you. The culprit, it was probably a copy and paste error. They did extra line. There's 2 GoToFails back to each other, and it skipped one of the verifications, and hackers found that vulnerability and got in there. Let's look at this other one, Heartbleed bug. In April of 2014, a security bug was found in the code associated with software used to encrypt private information used by many companies, including Google, Instagram, Netflix. Later referred to as Heartbleed, the bug created a vulnerability and it allowed for the theft of private user information. The bug was patched, but not before damage had been done. Some hackers found a way to get in there and get a bunch of users, usernames, passwords, all kinds of information. And there's actually where the bug is, but I don't understand it. You have to understand what they're writing in and what the program. But that was where the error was. All right, let's look at some sample programs today. Program testing. All right, so the important part of testing, actually doing the testing. When testing programs, you want to be the one to find the problems, not the people using your program. So if there's any problems, you want to find them. So test your programs using every possible scenario and then test them again just to make sure. So having a testing plan helps make sure you don't miss anything. So ready to test some programs? All right. So as you can guess, when we write a program this week, you're going to need to test it multiple times. Let's look at the sample program they gave us here. All right. Hashtag testing code. So they define a function called convert temperature. Convert temp with whatever temperature you enter. And here's what the function does. New temp equals temperature minus 32 divided by 5 times 9. 32 divided by 5 times 9. And then return whatever that new temperature is back to the function. So here's the main part of the program. Temperature, it's a float value because you might enter a decimal. This is an input, so when you run the program, it's going to ask you to enter a temperature. And then it's going to say print the new temperature is whatever that function calculates, degrees, main. It says, all right, let's read over the code. You'll see a statement starting with the keyword return. So a return statement sends a value back when you call a function. That's what it sends you back, new temp. All right, let's run the program. Run. Now it asks for a temperature. So let's put in a temperature that we should recognize. Let's do 32 degrees because we know what 32 degrees. Now, we don't know if this is having us input Fahrenheit or Celsius or anything really, but let's put in 32 and see what it gives us. It says the new temperature is negative 22 degrees. Well, I'm not sure what's going on, right? If 32 was Celsius, then the Fahrenheit would be a lot warmer, right? Fahrenheit, that's like 85 degrees or whatever it is. I don't know what it is. If I entered 32 degrees, it was Fahrenheit, that should be the same as 0 degrees Celsius, right? 0 Celsius equals 32 Fahrenheit. But it gave us back a negative 22. So either something's not right or this is using some total different scale altogether. So let's look at an improved version here. So now they've gone in and they've said, oh, let's put parentheses around. It looks like now they're telling us this is a Fahrenheit to Celsius. So it should have given us a 0 because it's taking your Fahrenheit and converting it to Celsius. So now we know something about it. And it said the formula should be this. All right, hashtag, so that, Python's ignoring this. Celsius equal Fahrenheit minus 32 times 5/9. Okay, that seems right. That seems right, right? So then they put in the Python code. Celsius equals Fahrenheit minus 32 divided by 5 times 9. Return the Celsius temperature. So now they define it like this. F would be the Fahrenheit equals float input into a Fahrenheit temperature. This is better. C equals convert to Fahrenheit. So that means it's calling this function. See, that's the same name. Convert to Celsius. I'm sorry. C equals convert to Celsius with whatever we entered, because they saved it right there. Whatever we entered, take that temperature and run this function. And so it says, okay, whatever they enter, we're going to take that and convert it. Now we're going to print string F, which is the temperature we entered as Fahrenheit. Oh, there's an ASCII character. That's probably going to be the little degrees symbol. And it says Fahrenheit is equal to, and then it does the same thing with our converted Celsius. So let's run it and see. Run program. All right, we're going to enter 32 again because we know that's 0 degrees Celsius. Now let's see what the program does. It says 32 degrees Fahrenheit is equal to negative 22 degrees Celsius. Okay, so while the program is much better because now it tells us what it's doing, it tells us it's a Fahrenheit temperature that we're entering, it tells us it's converting to Celsius, we know what the program is supposed to be doing. However, we also know there must be a problem because that's not right. It's not negative 22 degrees Celsius. But the inputs and the output are very clear now. They've made that better. But, we can test something else. Let's run another one. What if it's 212 degrees Fahrenheit? That should be 100 degrees Celsius, right? Oh, that says it's 158 degrees Celsius. That's not right either. That number's too big. What if we put a negative? What if it was minus 5 degrees Fahrenheit? It says that's negative 59. I think that's too big of a number or too small since it's a negative. So there's still some problems there. And it looks like if we look at this formula, they've messed things up when they put it in Python. For one thing, this is 5 divided by 9. This is 5 multiplied by 9. So yeah, there's obviously something wrong. They have it correct here, but they wrote the code wrong. All right, let's look at the next improvement. All right, they still have Fahrenheit minus 32, which is correct, but they've switched the divide and multiply. It's backwards. What have they done down here? Oh, they start out setting each to 0, Fahrenheit 0, Celsius 0. Again, they have as input a Fahrenheit. Then they run the convert and do the same thing. So let's run again, see if this is better. 32 degrees. They've not fixed anything on the calculations. It should be 0 degrees, but it's still negative 22. There's a number of errors with this. Oh, there we go, right there. Number of errors with this right here. So let's look at the next improvement that they did when they went and tried to fix that. It says run the program and type 32 degrees, 32 Fahrenheit. Nothing has changed. All right, so they need to fix some things. This should be parentheses to where it does that first, because the order of operations would do that last. It's a subtraction. Let's change this to a multiply, change that to a divide, and see what that does. Does that fix it? 32. Hey, looky there. Now the output says it's 0 because this was incorrect. This needed to be in parentheses, and these were backwards. It needed to multiply by 5 divided by 9. So that's great. You're testing numbers. You find it. Let's try the 212 degrees. That should be 100 degrees, right? 100 degrees Celsius. Okay. A little testing. All right, what do we have here? Let's read over the code. Here's a function called absolute value of x. Return the absolute value. So this is a function that when you enter a number, it should give you its absolute value. Now, if you remember absolute value, that's the distance from 0. So absolute value cannot be any negative numbers. The absolute value of negative 7 is 7. The absolute value of 7 is 7 because they're both 7 away from 0. The absolute value of negative 400 is 400. It's not negative 400 because absolute value is not negative. All right, so here's the program. They say if it's less than 0, return that plus a -1. If it's greater than 0, just return the number, because the absolute value of 25 is 25. Absolute value of 3 is 3. You don't change anything. And now it assigns a number, -12, and it says print the absolute value of -12 is, and it's going to run that function up there to evaluate it. So let's run the program. The absolute value of -12 is -13. Well, that's wrong. So you're happy with the results of the program? No, they've done something terribly, terribly wrong. Let's look at their update. Now, what have they done? If x is less than 0, return x plus -1. I don't think they've changed anything. Oh, they've changed this. They're testing 5 different numbers now. They made a number list. -12, 12, 0, 9.8, -9.8. And the answer list. This is what the absolute value should be. All positive. The numbers don't change. It's just all negatives become positive. So then they made a for loop, and they're going to go through the number list, calculate the absolute value, and then say, is it correct? So they'll check it against the answer list. Let's run it. The absolute value of -12 is -13. False. So this is a program they wrote to test their program. The absolute value of 12 is 12. That's true. The absolute value of 0 is none. That's false. The absolute value of 9.8 is 9.8. That's true. The absolute value of -9.8 is positive. Is -10.8. That's false. So if we look at what they did up here, what's wrong? It shouldn't be plus -1. It should be multiplied. If it's a number that's less than 0, means if it's a negative number, to find the absolute value, just multiply it by -1. Make it a positive number. So that should work. Let's run it again. Oh, look. -12 is 12. That's true. -9.8 is 9.8. That's true. The only problem is it's saying 0 is none. Well, that's not correct. So let's put in another statement here, another elif. Oh, back up. Elif x equals 0. Return 0. If it's 0, then it's 0. Let's run it now. There you go. The absolute value of 0 is 0. That's true. So now they're all true. It'll do negative numbers. It'll do positive numbers. It'll do 0. But we had to test all 3 values to understand where the error was. Because if we would have tested it just saying, what's the absolute value of 12? It would have said 12, and we're like, okay, great. The program works. But it didn't work. All right, let's look at our assignment. I'm going to open up that Python window just a moment. All right, looking at our assignment, the template is in Google Classroom, but here's what it looks like. You're supposed to write a program that converts or calculates some kind of value. All right, so some kind of math. You can pick what you're converting and then use these guidelines. Think of a program that requires you to convert or calculate 2 different types of values, right? Fahrenheit to Celsius, feet to meter, however you want to do that. Some examples may include converting between inches and centimeters or calculating distances, kilometers to miles, whatever. Write a function that performs the calculation. Double check your formula in units. Like, does it require meters, but your value's in feet? And then you need to run your program and determine a set of at least 3 values to test it. You need to test it multiple times. When you turn in your program, that's what I'm going to do. I'm going to test it with positive values. I'm going to test it with negative values. I'm going to test it with 0. I'm going to try to find a problem. Testing it. So it says use integers, use floating point. I'm going to put a decimal. I'm going to put 3.3. Does that make your program have an error? Negative, positive. And then create an output to display the results. All right, so write the pseudocode. The program itself is not hard, right? You're just calculating values. You just need to remember, what if they put in a decimal number? What if they put in a negative number? Does that cause a problem? So when you run your program, that's what you should do with it. All right, I wrote a program, and I actually did 2 different conversions. I was just having fun with it. So let me put my program up here. All right, Mr. Brock, April 8th, 6.01 testing program. I did 2 functions. You don't have to do 2 functions. You just have to do one. But I did a conversion to beard seconds. Yes, there's something called a beard second. And a beard second is the amount a beard grows in 1 second. It's a very, 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 very small number. But there is a unit of measurement called beard seconds. And look, in 1 inch, there's 5,080,000 beard seconds. So it takes that many seconds for beards to grow 1 inch. It takes 5,080,000 seconds for a beard to grow an inch. I also did a different conversion to something called a Pottersheebie. Pottersheebie. I don't even know how to pronounce it. A Pottersheebie. So here, let me just run my program first. Run. Enter a number. Number cannot be less than 0. I'm going to enter just like 5 to start out with. All right, let's convert inches to other more interesting units of measurement. A beard second. I went ahead and put this in my code just because nobody knows what a beard second is. You don't have to do this, but a beard second is defined as the length that the average beard grows in 1 second of time. So 5 inches is equal to, 25,400,000 beard seconds. A Pottersheebie, here you go, Pottersheebie, which was created by Donald E. Knuth back in the 50s, is equal to the thickness of Mad Magazine issue number 26 that was published in November of 1955. He actually created a unit of measurement based on the thickness of the magazine. So 5 inches is equal to 56.1115544 Pottersheebies. So that means you would need 56 issues of Mad Magazine 26 to create a stack that's 5 inches tall. Like I said, I'm just goofing off. I'm having fun units of measurement. I didn't do inches. I didn't do Fahrenheit, but you can do Fahrenheit, whatever. But you need to write a program and then check it. See, I've checked it with 5. What if I put 0? Does it create an error? No. 0 inches is 0 beard seconds. 0 inches is 0 Pottersheebies. It's fine. How about if I put in -10? Does that create a problem? No, that's just negative 50 million beard seconds. 10 inches is negative 112 magazines. Now, that doesn't really make sense in the context of what it's talking about. You don't have negative number of magazines. So maybe I should change the program and say negative values are not applicable in this case. A beard can't grow negative inches either. So let me try something else. 2.5. Does it work with decimals? Yeah, 2.5 inches is 12,700,000 beard seconds. 2.5 inches is about 28 issues of the magazine. So it works with decimals. So that's what you're doing this week. That's what you're doing. You're writing a simple program just to do some kind of conversion, mathematical conversion, and then you're going to test it. Positive numbers, negative numbers, 0, decimal numbers, whatever. It doesn't have to have an input. You could put those numbers in there automatically to just test each one. However you want to do that. I just figured an input was easiest for mine. I'll just enter a number and then it runs and see if it works. So you're trying to break your program. You're trying to figure out, is there something I need to fix? So that's what you have this week, guys. Write your pseudocode, put your program together, turn it in on the template. Don't forget to answer the questions at the bottom. But all right, that's all we got this week. If you need help with your program, that's wrong. It's an A-Day Friday. So we'll have class Wednesday and Friday for anyone whose grade's below 70 or anyone who wants to come in and get some help with your program. So I'll be here Wednesday and Friday for class. So as long as I don't get sick this week, that wasn't any fun. All right, guys. Have a great week.